But this ice may be many kilometers thick. To penetrate the ocean and search for organisms must await a landing. Nevertheless, the grooves and fissures that network the surface are cause for hope. They're reminiscent of frozen oceans on Earth, and what life teems beneath their ice. The Big Four of Jupiter's 16 moons, a mini solar system. Liftoff for Cassini, last of the big spenders. It's 1997 and 5.5 tons of spacecraft head for Saturn. Cassini reaches this exotic giant in 2004. The mission costs $1 billion. So what prompts this costly and lengthy undertaking? Our world is just 150 million kilometers from the sun. Sweep out past Mars, last of the terrestrial planets, and cross the Great Divide to Jupiter. Saturn is beyond. This beautiful planet is nearly 10 times farther from the Sun than is Earth. Its solar orbit takes almost 30 years. Its daily rotation, 10.25 hours. After Jupiter, Saturn is the largest planet, so buoyant that in an ocean big enough, Saturn would float. Yet it could swallow Earth nearly 750 times. Like Jupiter, Saturn is gas, 94% hydrogen, the rest mainly helium. And it has similar weather bands, but haze makes them hard to see. They're revealed by changing camera filter, full of storms and eddies. Winds are faster than on Jupiter. This jet stream blows at 1,500 kilometers an hour. Saturn's atmosphere has 5 layers, with haze at the top, then crystals of ammonia ice, ammonium hydrosulfide, water ice, and water droplets. Deeper still to hydrogen and helium, then liquid hydrogen, metallic hydrogen, and a rocky core. As with Jupiter, it's the metallic hydrogen that generates Saturn's magnetic field. It diverts the solar wind, except where electrified particles funnel toward the poles. They generate aurorae. Watch the North Pole. From afar, the rings of Saturn are like gossamer. Close to, there are billions of moonlets, from specks of dust to icy rocks the size of trucks. On a scale we can appreciate nearer home, the rings stretch so wide that they'd fit between our planet and the orbit of the Moon. But they're no more than a kilometer thick. From Earth, our view of the rings changes as Saturn orbits the Sun. It's because of the tilt of the axis, 26 degrees. Edge on, the rings virtually disappear. Our knowledge of the rings is through the Voyager flybys of the early 80s. They reveal 7 main bands, each with hundreds of ringlets. And they record time-lapse of mystery spokes, possibly dust levitated above the rings by electrostatic forces. With a background star as reference, Voyager catalogues the rings and their divisions. This largest gap is the Cassini division, 4,000 kilometers wide. Some of the rings are kept neatly in orbit by little shepherd moons. Here's a pair marshalling the outermost ring. This moon, called Pan, orbits within the Encke division. But the rings are a puzzle. They may be the debris of pulverized space rocks, too close to the planet to clump together as moons. Within a few million years, the rings of Saturn may well disperse. Voyager time-lapse of Saturn and its moons. There are 18 known satellites. Tiny Mimas is one of the oddest, ice and rock and a gigantic crater. Had the projectile that caused it been bigger, Mimas might be a Saturnian ring. Enceladus, nearly twice the size, but still just 500 kilometers across. Plains of ice formed perhaps as water welled up from beneath. Icy fountains may still spurt here as Enceladus is flexed by the pull of its neighbors. Next in Voyager's sights, Tethys, over 1,000 kilometers across, and a great canyon just visible at the underside. Dione is similar, but with one hemisphere brighter than the other. An icy surface of craters and troughs. A close-up of Rhea, a big moon 1,500 kilometers wide. Iapetus has one hemisphere coal black, the other snow white. Tiny Hyperion is like a distressed hamburger. And this little rock periodically swaps orbits with a twin. Saturn's biggest moon, larger than the planet Mercury, is discovered by telescope in 1655 by the Dutch astronomer Huygens. The moon is Titan, and it's a little like early Earth in deep freeze. Titan is veiled in haze, but Voyager senses the presence of organic molecules, carbon-based compounds like those that sparked life on Earth. We can only guess at the surface, for Voyager sees nothing through the all-enveloping smog. Hail Cassini. On its arrival in 2004, Cassini deploys a lander, appropriately named Huygens. The descent takes 2.5 hours. The atmosphere is rich in nitrogen, just like Earth. Data is flashed to the mother craft and onward to Earth. On landing, Huygens has just 30 minutes of life. Temperature is minus 190 Celsius. There's no sun for solar cells, and it's snowing ethane and methane. Titan may have oceans of hydrocarbons, but Huygens can also handle a splashdown. Again, only half an hour to signal Earth with those vital clues. Is Titan a laboratory for life? That's reason enough for this billion-dollar mission to the Lord of the